Hello everyone. Today I'm going to show you the multiplexer I built last time working. So if you remember last time I built this 8 to 4 multiplexer. So it takes an 8-bit number, splits it in half, and outputs one half of that signal as. So it takes in 8 bits, outputs 4 bits. And I also had a clock set up on the breadboard here that would automatically switch between them. I've now built that clock circuit onto a matrix board and stacked it on top of that, and it just feeds directly into that. The power and ground are on the same side pins, so that would just be wire wrapped together. This can easily be wire wrapped, so this will basically be unnoticed. It's got two little lights here. These are different colours. One's pink, one's red. So they have the same resistor value in them, so they're actually the same. Well, they're different brightnesses because pink is just naturally brighter. Yeah, so I should have probably used a higher resistor on that, but I'm not too worried about it. It's not important. It's just showing you that the speed of the tick. So yeah, as you can see, I've got an 8-bit number here wired in. Let me move that out of the way. So what it is at the moment is low low high high is one half, and the other half is high high low low. So that will go through here, get switched automatically. It's like it's like 2 hertz or something if it swaps over, and it will output that interchanging number here. So you'll see these two light up, then these two light up, and it will just switch. And I'll show you that when you change the input, the output changes as well. So I'll just turn it on. You'll see these two lights alternate, and you'll see the output here change. So yeah, as you can see, pink and red. At the moment, it switches on the red side, but you can actually just swap that out and put it on that one. These are both the same. But I had two because, well, I originally had this a plan to put a demultiplexer on here as well, which has these 2 outputs. But I figured I could just use this clock, this half of the clock instead, and just have the demultiplexer on the brand new LED display. Because the new LED display, the 7-segment display, it will have 2 7-segment displays on it, and I might as well just put the demultiplexer on that so you can choose which one it's actually displaying on. So currently this is in slow mode. As you can see, I've got these little jumper pin things, jumper headers, whatever they're called, and they connect these large capacitors which slow the signal down. If I remove those, you'll see like the frequency speeds up a lot, and it will basically look like these are on all the time, even though it's still switching between them. So I'll take them out. As you can see, that's just one half taken out, but it's still going fast. You'll see that these ones are dimmer. That's because that's on the fast pulse. So it switches to that, then switches back really quick and stays on for these ones longer. But if I remove both, they should be the same brightness. Yeah, there you go. So that's what it would actually be running in. So you'll have 2 displays. It's switching between numbers, but it will look like they're both always displayed, simply because it's ticking over so fast. And to slow it down again, you just put the pins back in. I could have probably done this like a circuit to control this, but I figured not really worth it, because you're not going to be doing this often. And this board will be on the top, so it's quite easy to fix it up to test it. But yeah, as you can see, it slows it down again, and you get the signal. So yeah, that's that. Some other things I've been working on is I've been trying to lay out where this will fit in the whole computer build, and still trying to fix some issues there. If you remember when I fixed my decoder stack, I just disconnected the resistors on the AND gates. It turns out that that's fine if you're trying to get a signal out of that AND gate. It sort of boosts it up a bit. But if you're trying to get a signal out of another gate, there's still a little bit of residue, a little bit of... There's still voltage there which you don't want, because there's still... some of the gates are still open. So I had to put those resistors back, and I'm doing other things now to try and boost the signal. So, because most of the logic in this computer it's like direct logic, it's not inverted. With inverted logic, like NAND gates and NOR gates, you tend to start off with the high, like a a 5-volt signal, and any input gets rid of it. But I'm using direct logic currently, so things like an AND gate, the more inputs you have, the lower the voltage is going to be at the output, because you start off with 5 volts, then you go this resistor, or this transistor, there's a voltage drop, then this transistor, there's a voltage drop. By the end of it, you end up with like 3 volts, which isn't enough for circuits down the line. So I've been building some little contraptions, like this. This one's actually wrong. This is again direct logic. The idea here was that put an input here and it will just connect it to 5 volts. But because the inputs were still so low, it didn't actually boost it up to 5 volts. It was actually less. So this was crap. I'll hold on 1 second and I'll get the one. Right, so this is the one I just had connected to the computer. So this is inverted logic. So this is actually 2 inverters. So what happens is, so I did an experiment. So it's, if you have a low voltage, you can't really or low voltage or a low current, you can't really use a transistor to boost that directly. You can't just say, oh, put this in the base and then that 5 volts will go through. That wasn't working. But if you have 5 volts, put in a very small signal into the base of a transistor, it will happily go to ground. So inverted logic works a lot better. So what this is 2 inverters. There's actually 4 here, but this is for 2 pins. So you have an inverter here and an inverter here, or NOT gates. So when you put a low signal a small signal into the base, it will connect it to ground. So whatever was here will just go straight out. It doesn't care how small that signal was really. And yeah, so say you input a 1, that would then output a 0. That's why you have the second inverter, because that takes that 0 and outputs a 1. And because you start off with 5 volts, it actually boosts that signal up to 5 volts. So that fixed a lot of the issues I was having. It's still not perfect, like the 7 segment doesn't come on very nicely. This works, but I need to make another one of these for some other parts of the that go into the decoder board. So actually what would happen is these bits would actually go in here. They'd actually go onto here somewhere. Or somewhere in the middle, hanging in thin air, I don't know. But basically, between any weak outputs, I will need one of these. From now on, I'm actually going to start trying to use inverted logic, like NAND gates or NOR gates, to build up circuits, as that's more reliable. But yeah, another thing, like fixing the signals, like where the decoder is or where the adder is. Like at the moment, it's between the adder and the decoder, and these are okay. But it's still a problem when you go from the decoder to the diode matrix, which takes your one of 16 signals and outputs 7 signals to drive the display. Because it's built on diodes, there's a voltage drop there as well, and that's not quite enough to drive the LEDs. So yeah, I might have to put another board on top of the diode matrix board to boost those input signals. But for now, it works and it's just dim, so I'm happy with it for now. I'll just build another one of these, fix it up. Hopefully get all this wired up, because this is all working now. Yeah, so I'll get all this wired up, and then we'll have one 7-segment display which switches between 2 numbers. And then after that, it'll be building another 7-segment display, or with 2 on it. So yeah, that's that. I got a couple of bits of posts, though I don't think it's anything amazing. I'll open this one first because I know what it is. There we go, it's my scissors. Right, so these are just some battery packs. Some, what are they? 4.5 volt battery packs for AA's. It's got some holders here as well. I don't know if I'll need them, but I thought it was cool. This is actually the cheapest set I could find, and it came with extra stuff, so I was like, why not? So yeah, you've got these little battery holders. You can just if you need them. But yeah, these are what I wanted because I haven't actually got any of these. So the reason I got these isn't for the computer build. I don't know if well, maybe I could run the computer off 4.5 volts, I'm not sure. These are actually for something else I'm going to start working on, like multiple things. Sort of like art pieces, and they'll be battery powered, or they'll have a mains connection as well, an optional mains connection. I won't go too much into them. I'll just show you in the future when I've actually built one. But yeah, my mum is now running a craft shop, Sunday market, and she was hoping I could sort of make some things to sell there. So yeah, that's something I'm going to be working on. And there's 6 of these, so that'll be 6 things I might build. Yeah, at the moment I just need to set up my like a bigger desk because I really don't have much space to work on larger things. So yeah, but that's that. Those are quite cool. And I didn't take my address off this, so it's upside down. I can't recall what this was. Oh right, yeah, okay. God, I thought these weren't meant to arrive yet. But yeah, these are some new test leads. So here's my old multimeter. My test lead, the black one, actually broke, but I did fix it. As you can see, I sort of had to cut it all up, managed to pull it out, and just resoldered the wire to the metal. It's a bit dodgy now, though. I don't know if it's the connection there, but sometimes this multimeter just reads out, like when it's meant to read out 5 volts, it'll read out 10 volts. It just seems to double everything. Turning it off and on again seems to fix it, so I don't know if it's the lead or the multimeter. But it's annoying, but it's not the end of the world. But yeah, I got some new ones of those. Okay, that's the lid. Let's give this a quick look. Hopefully these are the right connections, because it didn't actually say on the listing when I bought them what connections they were. Yeah, they look alright. These are the common connections. These ones just have much more of a shroud on them, but they seem to be the same. Let's just do a quick test. Test this resistor. Actually, do they have any of their own resistance? These are already better than my current leads. My current leads have like a 0.03 or 0.03 resistance by themselves. So yeah, let's test this resistor, see what we get. Put a little light on there. Wait. I don't know, this can't decide what it is. What actually is it? It's a 2.2k. No, it's just dropped it. It's a 220 ohm resistor. There it is. Let's put this down and test it again. Maybe it's just my multimeter. Yeah, that's better. Look, 220. Let's try it at 20k again. I just want to. I haven't seen that before. But then again, if I checked it was 220 beforehand, I wouldn't have done that setting. Oh yeah, there we go. That's better. Yeah, I think this multimeter is just weird sometimes. It just gets itself into the wrong setting somehow. But yeah, those are quite nice. Those are quite comfortable as well. They feel sturdier. I don't know if they come apart though, because that was the problem with the other ones. I had to cut them up to fix them. But yeah, that's all for today. Thank you for watching, and see you later.